So let's open it up for some questions. Do we have any questions? Yeah, there's one right at the back there.
John Eyre, CTO DWP. Listening to what you're saying there, is inherent in what we do in architecture the problem that you just articulated? That no matter how simple you draw the picture, there are 101 ways to misinterpret it and turn it into something convoluted. So you yourself have said the framework has been turned into an ontology, has been misinterpreted, has been populated for 3 years at a stretch, rather than treating it as a toolkit. Is this an inherent problem that we have to solve in drawing simple pictures for people?
You know, if you're trying to simplify the articulation of the issues for communication to other people, or you know, you're dealing with a fairly high level of detailed representation, and you know, the detail does not go away. You may use it for communication, but if you don't define the excruciating level of detail, it doesn't mean it doesn't exist. It means you didn't define it. Okay, so what that says is anything you do not define. If you took my framework and you just, you know, you colored in what you've identified, and some things you may have a high level of detail of the description of a cell, or some you may have only a portion of a cell. You kind of color-coded in. Anything that's not color-coded, you're allowing anybody and everybody in the enterprise to make whatever assumptions they want to make about what you never formalized, okay? So if you didn't formalize it, Leonard got into this a little bit today too. If you don't formalize it, you're allowing anybody to make assumptions they want to make. So you got to know that if you don't explicitly specify whatever any one cell is, you have a discontinuity built in because everybody's making different assumptions about it. Okay, so that's a source of defects. That's one aspect of the problem. The other aspect of the problem is if you don't understand the ontological structure and your classification is incorrect, you start trying to put composite constructs into the primitive cells. You put multivariable concepts into a single variable fact type. Now you know the analysis is going to be defective. Okay, so you don't have to do everything in excruciating level of detail, but you have to understand if you're not going to do the detail, you're allowing assumptions to occur. And the second thing is you have to be precise in terms of your understanding how to classify the different facts. So my framework is a two-dimensional schema that classifies all the facts that are relevant to the existence of the enterprise by definition. Okay, I'm spare you the pain of listening to the argument about this, but if you cannot classify a fact in that structure, it either is not relevant to the enterprise or you're probably trying to classify a composite construct. Okay, so it is simple, actually. It's a classification. So that's the way we'll deal with complexity. So if you're dealing with a high-level abstraction, it may be good for, you know, communication, but it's probably not, you know, adequate enough for doing the engineering. You may communicate at a high-level detail and then go back in and populate more detail or make sure the classification is correct, or, you know, that's the way you probably would deal with it.
Thank you.
This is regarding, I've been working on one of the largest public sector project earlier and implemented your framework. Worked very well for 7 years till 2011. And later on, there were lessons learned because of very large project, massive project, that RUP or waterfall model is not good enough. Now I'm struggling how to implement this framework so that it's effective in agile environment. Agile is something which we keep building, keep delivering, so it provides a value to the end customer. It's still working for government project, but that's something a big challenge now. And frankly speaking, struggling for last couple of years, how to use this framework, which basically Agile says for example, where you have sprints, normally bi-weekly or 4-weekly, monthly sprints, which deliver a production-ready code. But from architecture perspective, how do we apply agile on architectural framework?
You're articulating the problem from a manufacturing perspective, okay? The end object is trying to get something implemented. Okay, immediately, I know you're going to try to build a composite construct, because the implementation has to be, by definition, a composite. So therefore, we're trying to build a massive, big implementation. Maybe we're trying to build it incrementally, a few months at a time, but you can decompose it, one-dimensional decomposition. You can decompose it, but then you're going to have an integration problem. Okay, so I would just say, look, that is the classic understanding of enterprise architecture, which is coming from our 70 years of inertia of building and running systems. That's probably not a right concept. What you want to do is you want to change the fundamental concept to solve the general manager's problem. Forget the system. The end object is not to build a system. The end object is to make the enterprise do what the CEO wants it to do, okay? So, and you don't have to build any systems a lot of times to solve the problem. A system may not even require a problem. I wouldn't get into these long implementation projects. I would start out, say, okay, let's take a look at the CEO's problem. We'll just parse out whatever the primitive components we need to, and we'll pose some solutions to the CEO's problem, some of which may be a system and some of which may not be a system, may not even have anything to do with systems. Okay, so if it is a system, then what I would basically do is I would get the primitive components defined precisely and then create the implementation composite from the architected engineered primitives, okay? And that way you're going to end up with a integrated implementation, not a disintegrated implementation. So the problem is our perception that the end object is to build some implementation. Forget the implementation. That's a manufacturing idea. That's the old paradigm. That's where we've been for the last 75 years. You got to think about this from an engineering perspective. I want to diagnose the CEO's enterprise problem, and I just do enough, of the architecture work to diagnose that problem, and I can begin to populate the primitive components and then reuse the primitive components to create the composite implementation. That way, whatever the implementation is, you're reusing normalized single variables, okay? See, our idea is we don't think work is being done until the system is running. Forget that. The end object is not to get the system to run. But that's the paradigm we're laboring under. But it's easy to see why that happens, because we got 70 years of inertia. We've been building systems. In fact, if you ask somebody from IT what they do for a living, we say we build and run systems. That is a manufacturing. We don't say, well, we engineer enterprises and diagnose the enterprise CEO's problem. We don't say that. So that's what we ought to be saying. We ought to be the enterprise doctor, for goodness sakes. We end up being the X-ray technician. We're taking snapshots. As soon as you create a composite, it's a snapshot. It's a point in time. It's good for the moment. Every minute after that, it is obsolete. We already know this. The system is good the minute you turn it on the first time, and every minute thereafter it begins to deteriorate. Okay? So that's a composite. It's the nature of a composite. It's a snapshot. It's a point in time. The CIO of the federal government in the U.S., some guy, he terminated a lot of enterprise architecture projects for exactly this reason that you're describing, because they take a long time and they cost a lot of money. They create a picture that goes on the shelf and never affects reality. It doesn't do anything. It is not implementable, in fact. So therefore, it's a snapshot. It's a point in time. So the picture is not implementable. So he was very proud of saving the federal government of the U.S. billions of dollars. What he did was correct, but for the wrong reason. Okay, it was correct because The architect, the concept, he didn't have the understanding of architecture. He didn't understand what architecture was. Architecture is not the instantiation, is not the composite. The composite is the implementation. That's not architecture. The primitives are architecture. The composite is the reuse of the primitives to create the instantiation. Okay, so the concept was wrong. It goes back to, I'll tell you what, we see this all over, forgive me, I'm going to really aggravate somebody now I say this. But, you know, enterprise, the question is, which is, how do I want to articulate this? The frameworks that we have today typically are not ontologies. They are methodologies or methodologically derived. Okay, the methodology by definition produces a composite. The primitives are the single variables. So, okay, so, you know, my framework, it was by accident. I wish I could tell you I was so smart I knew this at the beginning. I didn't know this at all, okay? I learned more about enterprise architecture in the last 5 years than I learned in the last 25, you know. My framework turns out to be an ontology. It is not a methodology. It does not imply anything about how to do it. It doesn't imply anything, top down, bottom up, left or right to left, where to start. It just says this is the total set of facts, you know, classified so they could be normalized, single variable facts in every category, basically. That's all it does. It doesn't do anything. It doesn't do anything. It's just a schema. It's a classification. So you classify things not in order to deliver implementation. You classify them in order to diagnose the problems, understand what the engineering characteristics are, and so on. Now, the methodology will create an implementation. So the question is, did you have an ontology first to create the composite implementations from? Or did you just create a composite ad hoc to a problem or an implementation, some system you want to implement? If you created it just for an implementation to solve a problem or build an implementation, it's going to be implemented, which is good. I'm not saying it's a bad idea. It's a good idea, but it's not architected. Okay, it's implemented but not architected. You've hard bound together independent variables, so therefore it's not flexible, it's not integrated, not reusable, it's not interoperable, it's implemented. Don't forget that, it's implemented, that's really good. So the question is, did you start with the engineering structure, which is a two-dimensional schema, in order to create your composite implementation, or did you just start building implementations? And so therefore, you know, you have two different kinds of things going on. You got engineering things, which is the fundamental idea. It turns out to be an ontological construct, which is basically my framework by accident. I happened to stumble across. Or, you know, and a methodology. The methodology is the implementation. That's the manufacturing issue. Okay, so it was Alan Brown, who is the owner of the Open Group. Some of you guys know Alan Brown. You know, probably 10 years ago or more, Alan was introducing me to a TOGAF conference in Johannesburg. And I happen to know Alan Brown, but without any prompting from me, I didn't know what he was going to say. When he introduced me to a TOGAF conference, he said, I thought for years that it was either TOGAF or Zachman. That is incorrect. It is TOGAF and Zachman. You need an ontology and a methodology. If you only have a methodology, you're going to produce, you know, what we got. We're not using an ontology. If you have an ontology with no methodology, you're not going to have any implementations. Now I used this metaphor the other day, the periodic table metaphor. Some of you guys heard me use this metaphor. Before Mendeleev defined the periodic table, there were a lot of chemists out there. They weren't chemists, they were alchemists. And they knew how to produce compounds. Let's call those composites or multivariable composites. They knew how to produce compounds. They were very clever. And they did some really astounding things, by the way. You know, but they did everything by trial and error. It was, you know, by personal experience. It was all by trial and error. So, well, No, I won't digress in that. But it is by trial and error. Now, after Mendeleev defined the periodic table, now they had identified what the elementary components are from which the compounds can be created. Up until they have the periodic table, they didn't know elements. There were no elements. There were only compounds. They were trying to make compounds out of compounds. They're making composites out of composites. Their meta model had composite constructs in it. It was just manufacturing. It was by trial and error. After Mendeleev produced a periodic table, whoa, now they have the theoretical structure of why those compounds get created and how to create, and now things become repeatable and predictable. Okay, but until they have a periodic table, it's all about experience, but best practices. But once you have the periodic table, it now becomes a discipline. Now it's a science, not a practice. Okay, so and I'm going to tell you something. When Mendeleev produced the periodic table, I'm sure that a lot of the alchemists were not all that enthusiastic. Okay? You hear what I'm telling you. So we don't need no periodic table. We know how to make salt water or whatever it is, what I'm making. So no, they weren't necessarily happy. However, within 40 or 50 years of Mendeleev's publishing the periodic table, those alchemists were splitting atoms. They didn't even know atoms existed. They had some suspicion, some of them did. So once you have the ontological structure, friction goes to zero. Okay? So the metaphor is a good metaphor, actually. The periodic table is an ontology. It's not a methodology. It doesn't tell you anything about how to do anything or what compounds to create or how to create them. It just tells you this is the total set of elements from which every and any compound in the universe is created. If you don't have the periodic table, all you have is a bunch of compounds. And you're working with compounds. And it's not a theoretical structure. Let's put this together with that and see if it works. Let's put it together, we'll see if it works. It's all trial and error. And one thing a lot of you guys don't understand yet, life is too short. You can't learn everything by trial and error. For 7,000 years, the alchemists never created aspirin, which is a fairly simple compound. But they did create gunpowder. Hey, that was pretty clever. Okay, so you understand, but you're limited by a lifetime. How much can you learn in a lifetime? Once you have the ontological structure, now it becomes a science. It's repeatable and predictable. Now research becomes a factor. So I have been arguing this case for a long time. We need the underlying theoretical construct from which we can create our composite implementations. But the reaction from people who are alchemists, people who have been manufacturing implementations for a long time, say, "Oh, that takes too long. It costs too much. I don't want to think about it. I got to get some code to run." Or there's a lot of objections to trying to use the ontological construct. So I'm not giving up, you guys. There's a couple of you guys that I haven't convinced yet, but I'm working on it.
Are you convinced?
Thank you very much. Yes, I understand now. So just summarize it. We need to have an architectural runway ready before we can have a delivery airplane to take off.
If you want to get free from the 5 to 7 year project, you probably need to start populating an ontological structure. Yep. You do that, and that becomes the front end to any implementations. And then you can create, compounds, small enough to do implementation in relatively short periods of time. That was a great question. I appreciate it a lot.